Hello. Today we're looking at day 5 in our Unit 3 notes. So if you guys would find day 5 here, we are going to start talking about parallel and perpendicular lines. All right, so I have a definition for both. We are going to add to this. So parallel lines, they are lines that lie in the same plane, lines in the same plane that never intersect. So parallel lines are lines in the same plane that never intersect. And when I am mentioning plane, a plane is just a two-dimensional space. So like this piece of paper you're writing on is a plane. It's just a flat two-dimensional space. So let's come back to parallel, but go ahead and write that definition for perpendicular. Perpendicular lines, they are lines that intersect to form right angles, and right angles are 90-degree angles. Okay, perpendicular lines are lines that intersect to form right angles. Okay, if you need to pause to write all that, please do, because I'm going to add a few notes here. All right, so parallel lines, if they never intersect, you know, they might look something like this. You might have a line here, you know, and a line here, and if they're never going to intersect, if you think about the angle of this line, like slightly going up and to the right, if it's never going to intersect, my second line has to have that same angle. So if you think about when you graph a line, what gives the line the angle? Well, that's your rise over run, that's your slope. So if these lines are never going to intersect, they have to have the same rise over run, okay, or they have to have the same slope. So let's add an important piece right here. I'll put a little star. So with parallel lines, they have the same slope. So I'm going to write here, parallel lines have the same slope. Okay, so that is important because when we're trying to write the equation of a parallel line, we want to use the same slope. All right, so parallel lines have the same slope. They have that same rise over run. It's going to give the angle, the line the same angle. Okay, perpendicular, we want them to intersect, and they have to intersect at a right angle. So if you had a vertical line and you had a horizontal line, those are perpendicular as long as you have this 90-degree angle right here. Okay, so this little box here is the 90-degree symbol. So perpendicular lines have a similar, or they have a concept on slope. So obviously we want them to touch. So if you think about what makes, if you have a slope going in one direction and another slope going in another, one should be positive and one should be negative, or else they'll never intersect. All right, so we need them to have opposite signs. To get them to make a perfect right angle, they need to be reciprocals of each other. So if you have a slope of up 2 over 3, the reciprocal of up to of 2/3 is 3 over 2. So it's reciprocal is when you flip the slope over. So let's add a little bit here. Okay, so I'm going to say here perpendicular lines. Perpendicular lines have opposite reciprocal slopes. Have opposite reciprocal slopes. Okay, so I'm going to kind of underline opposite and reciprocal. Okay, so opposite refers to, if numbers are opposite in math, one's positive, one's negative. Reciprocal is when you flip a fraction over. Okay, so if you want to add a note there, you can. So here's some examples. Let's say I gave you the number, well, let's just do the 2/3. Let's say I did 2/3. If I want the perpendicular slope, I need to be the opposite sign, so I need my new number to be negative, and I need to do the reciprocal, so it needs to be 3 over 2. These two slopes, if that was the slope of a line, would be perpendicular. How about, let's do -2 as my first slope. Well, the next slope should be positive, and then I need to flip over -2. So there's really a 1 under it. So my new slope would be a positive 1/2. Okay, opposite sign and then reciprocals of each other. All right, so that's the key element here. Same slope, parallel. Opposite reciprocal would be perpendicular. Okay, let's run through a few examples here. Number 1, are the graphs with the equations below parallel? Explain. So if two lines are parallel, they have the same slope. Okay, so I need to look at the slope. So I'm going to put a little note over here. This is what you should be thinking. Need to know slope. Okay, so you need to ask yourself, all right, well, what is the slope? If I can see they're the same number, then they're parallel. If they're different numbers, they're not. Okay, equation 1, this is in slope-intercept form. Okay, this is what I should recognize. This is in the form of y equals mx plus b, which is great because I can see my slope. So my slope is negative 1/3. All right, so if the second equation has a negative 1/3 slope, they're parallel. This is not slope-intercept form. I cannot determine m without it being in this format. So let's rearrange it and let's turn it into y equals. So we're going to solve for y. So I need to move 2x over here. So since it's positive, you're going to take it away from both sides. Okay, so these guys cancel, bring down 6y. And then I like to write the x term first and then the other number second, only because I know I'm building to mx plus b. So divide off 6, divide off 6, divide off 6. Y equals. All right, this needs to be reduced down. So you can use your calculator. If you don't know how to reduce on a calculator, if you have one that looks like this, it's pretty easy. I'm going to keep the negative out because I know the answer is going to be negative. But if I make a fraction and I hit equals, it'll reduce it down. As long as it's, what's the word? Not improper. I guess an improper fraction, the number on top would be larger. Or you could say, well, I'm just going to divide by 2, divide by 2. So negative 1/3 x plus 2. And now I can see my slope, is negative 1/3. So, are they parallel? Yes, and my explanation is, well, they have the same slope. So I'm going to say here, yes, they have the same slope. They have the same slope. Okay. So it's all about slope when we're trying to determine parallel perpendicular. Okay. All right, let's look at this extra example here. We want to find the slope of the line parallel and perpendicular to the graph of the equation. Now, the reason I keep saying the graph of the equation, if this is a linear equation, I can put it on a graph and I should get a straight line. So what I'm saying is if I were to get a line, what's the slope of a line that's parallel to it and perpendicular? Okay, so here are my answers. So I'm going to put the slope of the parallel line, the slope of the perpendicular. So again, find the slope. All right, so can I see the slope here? No, I cannot. 3 is not the slope. It is not in the form of y equals mx plus b. So we need to solve for y. So I'd really like you to actually pause the video because I want you to try that on your own. This is what we did here, so I want you to replicate that process. So go ahead and pause it, and when you start playing again, I'll work through it and show you how to do that. Okay, I'm going to move my 3x over. So negative 3x plus 12, divide by 4, divide by 4, divide by 4, and then y equals, so that does not reduce down, so negative 3/4 x, 12 divided by 4 is 3. Okay, so I am focusing on this number. This is the slope of my original line, okay? So in order to have a second line be parallel, I need the same slope. So my parallel line will have the same slope, but perpendicular opposite reciprocal. So I need to do this idea here. So I have a negative slope. This number is going to be positive, and then reciprocal is to flip it over. So 4/3 is my answer. Okay, try B. Go ahead and pause and work through letter B. Okay, this is in slope-intercept form. So remember, there's really a 1 in front of that x right there. So if I wanted to make it a little more clear, I could rewrite it as 1/7 x plus 4. So here is my slope. I don't need to do any extra work. So a parallel equation or a parallel line would also be 1/7. Perpendicular, I want the opposite sign, so it's negative, and I'm going to flip it over. So that would flip over to be 7/1, but I want to go ahead and just reduce it down and write it as just -7. All right. Well, I'm going to stop this video here, and then the next video we will finish out a few more examples here.